Hello, welcome to Chapter 4, homework questions 27 through 32. Question 27. Ben thinks that the slope ratio for this triangle is 7 over 10. Carlissa thinks the ratio is 10 over 7. Who is correct? Explain your thinking fully. So when you take a look at this, 7 over 10 or 10 over 7, well, we have a 35-degree angle and we have a 55-degree angle. So if we place our triangle so that the 35 degrees is over here, that means this would be 7 and this would be 10. Then the ratio for the triangle could be, based on the 35 degrees, it could be 7 over 10. If we make our triangle with the 55 degrees, so maybe more like this, then the 10 is here and the 7 is here, and then therefore the ratio would be 10 over 7. It doesn't say specifically the slope ratio for which angle, and so that becomes a problem because it depends on what the angle is. So who is correct? Well, they're both could be correct depending on what they're trying or which angle they're trying to look at. It depends on the angle that is being used to find the, it depends on, which angle is used as the slope angle. So once again, is it the 35 or the 55? So once again, as you guys are answering these questions, make sure you explain your thinking fully. Question 28. Use your observations from problem 4-26 to answer the following questions. So if you go back to your 4-26, that is your learning log. There was a couple different questions we answered at the end of class. Take a look at that and answer questions A, B, and C. Delilah did not have a tool to help her find the slope angle in the triangle below. However, she claims that the slope angle has to be more than 45 degrees. Do you agree with Delilah? Why? So when you're looking at this, and we're looking at the slope angle, which is right down here, the ratio is 6 over 4, or 1.5. And she is saying that these has to be more than 45 degrees. Well, if you go back and look at question 26, one of the things asked is, when is the slope ratio more than 1, and when is it less than 1? So this one is more than 1, so therefore, what did we say about the angle when it was more than 1? We indicated that the angle must be greater than 45. So, do we agree? Yes, we do. And once again, since the slope ratio is greater than 1, the angle must be greater than 45. Lyra was trying to find the slope ratio for the triangle below, and she says the answer is delta y over delta x is equal to 2.675. Isaiah claims that cannot be correct. Who is right? How do you know? So if you look at the delta y over delta x, from what we really just talked about, that ratio is greater than 1. And if the ratio is greater than 1, then the angle should be more than 45 degrees. Well, if the angle is 19 degrees, then that ratio should be less than 1. So who is correct? Isaiah is correct on this one. And once again, going through that the angle less than 45 degrees because the ratio is less than 1. And part C, without finding the actual value, what information do you know about x in the diagram below? So we know the angle is 76 degrees, which means it's greater than 45. So we know that the ratio must be greater than 1. So 9 over x must be greater than 1, which means x must be must be less than 9, because 9 divided by 9 would be 1, and then 9 divided by 8, you need the numerator to be bigger on than the denominator so that it's greater than 1. So x must be less than 9. Don't necessarily know exactly what that looks like, but we do know just from looking at it that since the angle is greater than 45, x must be less than 9. Question 29. Examine each sequence below. State whether it's arithmetic, geometric, or neither. For the sequences that are arithmetic or geometric, find the equation using T of n or A sub n. Refer to the math notes box in this lesson if you need additional help. The math notes box is going to be useful on this one. You probably haven't done these types of questions since core connections algebra. So unless you can kind of remember exactly how to do these from that, which has been some time most likely, you might want to go back and look at that math notes box. It's very helpful in being able to do these questions. So on part A, the difference between arithmetic and geometric is arithmetic is repeated addition, where geometric is repeated multiplication. So when we look at these patterns, we're looking for, are we adding or multiplying the same number over and over? And it has to be the same number. It can't, add 2, add 3, add 4, add 5. It's not just any pattern. It's got to be adding that consistent number over and over. So on part A, you can see that it is adding 3, so therefore we know what type of sequence it is. We know it's an arithmetic sequence. We want to be able to write the equation of that. So we need to know a couple of different things. We need to know what the common difference is. So therefore on this one, the common difference, I'm just going to say that's D. D is equal to 3. That's the common difference. And then we also need to know what term 0 is. So right now this term is term 1. The 4 is term 2. That's what the n represents. But I need to know what term 0 is, that initial or starting value. Think of your graphs as well. So we actually got to work backwards from 1, and that would be -2. So -2 plus 3 is 1. So we have the first term, or in this case, what I mean is the 0 term, so a sub 0 is -2. That gives us enough information to be able to write the equation. So we'll say T of n is equal to, that common difference is 3, so that's repeated addition. So to deal with repeated addition, we do 3 times the term n. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So that's adding 3 every single time, and then we started at -2. So for example, if we plugged in 2, this would be 3 times 2 minus 2, and that's a t, not an f. T of 2 is equal to 4, which is what it shows in the pattern. So just kind of a way to look at that, though. So you have this, and you're answering that it is arithmetic. If you choose to do a sub n, same idea. It's just a sub n is equal to 3n minus 2. It's just a different notation, but same idea. For problem B, we're going to add 5, and then it looks like we're going to add 7. So here's that example where we're adding 9 and adding 11. There's a pattern to that, but it's not arithmetic because it's not repeated addition. You're not adding the same thing over and over again. And for multiplication, to get from 0 to 5, you can't even multiply anything by 0 to get to 5, so there's no way it's going to be geometric. So this is an example where it's neither. Once again, it's still a sequence. That's fine. There's still a pattern to it, but it doesn't represent an arithmetic or geometric sequence. On to part C. We could add 2 and then add 4, so it's not going to be arithmetic. So let's go back on that one. Is there another way to get from 2 to 4? We could multiply by 2, and then 4 times 2, 8 times 2, 16 times 2. And I probably really shouldn't be using the x for multiplication, so I'll just put a dot. Times 2, times 2, times 2. So we do have a pattern here. We do recognize it as being a geometric sequence. And what do we need to know? Well, we need to know, once again, on this case, if you look at the math notes, they'll talk about a multiplier. So the multiplier in this case would represent 2. I'm going to call that b. So b is equal to 2. And then we still need to know the first term, so we need to work backwards here to get the first term. So if I divide by 2, that would give me 1. 1 times 2 is 2. So that first term, once again, a sub 0, is equal to 1. So for a geometric sequence, we would have t of n is equal to 1, which is that initial or starting, times 2 raised to the nth power. Now the 1, I guess, doesn't have to be there because it's 1 times, but so if you wanted to write it as just 2 raised to the n, that would work the same way. So on to part D, we have 5 and 12 to 19. It looks like we could add 7 each time. So this is similar to the first one, so that would be arithmetic. We're adding 7, so our common difference is 7, and the first term, if I work backwards, would be -2. So I just go back a term, because remember this is n equals 1, so if I want to know what 0 is, I work backwards, and that's why that's -2. So this will give us an equation. T of n is equal to, we're adding 7 each time, so that's 7 times n, but starting at -2, so -2. Question 30. Edwina has created her own shape bucket and has provided the clues below about her shapes. List one possible group of shapes that could be in her bucket. So we have the probability of an equilateral is equal to 1, which means that it's 100% true that you're going to have something in the shape bucket that's equilateral. And the probability of having a triangle is 1 out of 3. So once again, list one possible group of shapes that could be in her shape bucket. All right, so there's lots of possibilities here. As long as they're all equilateral, so things like an equilateral quadrilateral would be a square, so that would have to be included, or not have to be, but if you're going to do a four-sided figure, it'd be included. You're going to have your triangle, but we need to make sure that we understand that it is not just any triangle. We need it to be an equilateral triangle. That way it satisfies the equilateral part, since 100% of them are equilateral. And then we could go up to 5 sides. We could do an equilateral pentagon. We could do a hexagon, an octagon. It doesn't really necessarily matter. We just need to make sure that no matter what we choose here, is that it is equilateral. So equilateral, we'll just say pentagon. All right. And so what you have here, you have a square, equilateral triangle, equilateral pentagon, so that satisfies the 100% of them, or the probability of grabbing a equilateral out, 1, but also the probability of a triangle, because you only have 3 possibilities, and one of them is a triangle, so that would be 1 out of 3. If you added any more shapes, you'd probably need to go up to 6 shapes. 2 of them would need to be triangles, and the other 4 would have to all be equilateral, but also some other figure besides a triangle. Question 31. Renee has programmed her music player to play all 5 songs in her playlist in a random order without repeating songs. So you can see the playlist below. I Love My Mama, Don't Call Me Mama, Carefree and Blue, Go Back to Mama, Smashing Lollipops. Interesting. All right. So now on part A, it says, what is the probability that the first song is a country song? So how many possibilities do we have? 1, 2, 3, 4, and 5. So out of 5, how many are country songs? 1, 2. So 2 out of 5 would represent the probability that we have a country song. Next part B. If the first song is a country song, does that affect the probability that the second song is a country song? And the answer to that is yes, because if the first one's a country song, this one's now out because there is no repeating. So now we don't have 5 choices anymore. We only have 4, and we only have 1 country song left. So yes, it definitely does matter. It does affect the probability for the second country song, and that probability would be 1 out of 4 now, because there's only 4 possibilities left, and there's only 1 country song left as well. On to part C. As songs are playing, the number of songs left to play decreases. Therefore, the probability of playing each of the remaining songs depends on which songs that have played before it, which kind of just talked about. This is an example of events that are not independent. If Renee has already listened to Don't Call Me Mama, Carefree and Blue, and Smashing Lollipops, what is the probability that one of the singers of the 4th song will be Sapphire? Explain your reasoning. So we've already played 1, 2, 3 songs out of 5. That means there's only 2 possibilities left. And out of those 2, let's mark them off. We got Carefree and Blue, Don't Call Me Mama, and Smashing Lollipop. So, Lollipops. So now, what do we have left? I Love My Mama and Go Back to Mama. What is probably one of the singers of the 4th song will not be Safari. So we have Sapphire. I'm sorry. So this one has Sapphire, and this one does not. So it looks like it would be 1 out of 2, or 50% chance. And part D. To get home, Renee can take one of the 4 buses. Once she is on a bus, she will randomly select one of the following equally likely activities: listening to her music player, writing a letter, or reading a book. Her choice of bus and choice of entertainment are independent events because the bus that Renee took did not affect which activity she chooses. For example, what is the probability that Renee writes a letter if she takes the number 41 bus? What is the probability that Renee writes a letter if she takes the 55 bus? So it doesn't matter what bus she chooses in terms of the activity. They're independent of each other. So therefore, if there's 3 activities and one of them is writing a letter, no matter what bus she takes, it's going to be a 1 out of 3 probability, 1 activity for 3 possible outcomes. Question 32, use what you know about the sum of the angles of a triangle to find the measure of angle ABC and the measure of angle BAC. Are these angles acute or obtuse? Find the sum of these 2 angles. How can you describe the relationships of these 2 angles? So we're looking at a couple different questions here. We do have a right triangle. So we know that the sum of the angles of a triangle add up to 180 degrees. So we know 180 is equal to the 90 degrees of the right angle plus the 2x plus 2. That's one of the angles. I'll put it in parentheses so you can see that. Plus the other angle, 6x plus 8 degrees. And we can solve that for x. So we'll first subtract the 90 degrees. And some of you might have set up your equation more like this first part here, 90 degrees is equal to 2x plus 2 plus 6x plus 8, knowing that these 2 acute angles have to add up to 90 degrees because you already have your right angle, so that's a possibility. Combine the like terms, 8x plus 10, subtract 10, divide by 8, and x is equal to 10. Now, to make sure we're answering the question, it wants to know the measure of angle ABC. So angle A, B, C, and you need to go in that order. A, B, C. So we're looking for this angle right here. That's 2x plus 2. 2 times 10 plus 2 would be 20 plus 2. So therefore, the measure, you have to write this correctly, of angle A, B, C is equal to 22 degrees. Now we're going to look at angle BAC. So now we're going B to A to C. So we're going in this direction now. BAC. So now we're looking at this angle. And that's the 6x plus 8. So 6 times 10 plus 8, 60 plus 8 is 68. So now we know that the measure of angle BAC is equal to 68 degrees. Are these acute angles or obtuse? They are both acute angles, which we could have been able to tell before we solved because we have the 90-degree angle, so the only thing left is 90 degrees from 2 angles. Find the sum of these 2 angles. We know the sum of the 2 angles, 22 degrees plus 68 degrees, will add up to 90 degrees because that's what was left from the triangle angle sum theorem. So the 2 angles will add up to 90 degrees. And how can you describe the relationship of the 2 angles? Well, since they have to add up to 90 degrees, we know that the 2 angles must be complementary. So they must be complementary angles. And I think we've answered all the questions. We found the measure of the angles and answered those last couple questions as well.